Welcome everyone. So this video is lecture 5, or it's the lecture over chapter 5 in the OpenStax Principles of Microeconomics course. So you can get the text if you go to, let me just go all the way back here. If you go to openstax.org, then under subjects to business and then to economics, and then you can get the book as a PDF, or if you click through, you can get the HTML version. You could also go to my text, which is available on Substack, microeconomicprinciples.substack.com. And you have to search a little bit, but you can find my chapter all about elasticity. And this has my write-up. And then it's got a link to my YouTube video. I look different there. It's literally called All About Elasticity. And then also, sometimes also important for when you're studying elasticity is the link between elasticity and revenue, which we saw a second ago is like chapter 7.1 on mine. So I recommend those also. But here, this is going to be following along specifically with the OpenStax slides. Right, so in this lecture, we are going to talk about price elasticity of demand and price elasticity of supply, polar cases of elasticity and constant elasticity, elasticity in pricing, and then elasticity in other areas than price, namely like income and, cross elasticity of price. Let's see. So Netflix and economic elasticity. Many on-demand internet streaming providers such as Netflix have introduced tiered pricing levels for access to services, begging the question, how will these prices affect buyers' purchasing choices? Well, to know that, to be able to answer that, we have to know how responsive are Netflix subscribers to changes in price, right? And that's a question about elasticity. Elasticity is an economic concept that measures the responsiveness of one variable to changes in another. So actually, elasticity broadly applies between any two variables. In economics, usually when we talk about elasticity, we mean that actually shorthand for price elasticity of demand, though there's an income elasticity and a cross elasticity, and there's price elasticity of supply. Price elasticity is the ratio between the percentage change in quantity demanded or supplied and the corresponding percent change in price. This is the definition, and this is a mathematical definition. So this like literally gives us the formula, right? It's percentage change of quantity demanded divided by percentage change in price. So this is a good definition to memorize, because if you can memorize that definition, then you know how the formula that you might need to memorize also works. Okay, price elasticity of demand is the percentage change in quantity demanded divided by the percentage, so this should be percentage change in price. And then the percentage change in quantity supplied divided by the percentage change in price is price elasticity of supply. All right, so then we have our delineations between elastic, inelastic, and unitary versions of of elasticity. Elastic demand or elastic supply is very responsive. Inelastic demand or inelastic supply is very unresponsive. And then unitary elastic is basically proportionally responsive. Okay, so this is a good description in this table of what the formula looks like. So it's percentage change in quantity divided by percentage change in price, right? Okay, the next thing is this formula, like this relationship is a fraction. What we know about fractions is if the numerator is greater than the denominator, the value of the fraction is bigger than 1. Right? So think of like 3/2 or 4/3 or 10/3 or whatever. If the numerator is smaller than the denominator, then the value of the fraction is less than 1. So you're thinking of like 1/3 or 2/5 or 3/4 or something. Well, it turns out that numerator and that denominator has an important interpretation. The numerator is the percentage change in quantity. The denominator is the percentage change in price. So if the percentage change in quantity is bigger than the percentage change in price, we'll get a fraction that's bigger than 1. And because the percentage change in quantity was bigger than the percentage change in price, it tells us we changed price a little, quantity changed a lot. That's pretty responsive. That's elastic demand. If the percentage change in quantity is less than the percentage change in price, the numerator is smaller than the denominator, we'll get a value that's between 0 and 1, and that's pretty unresponsive demand. We changed price a lot, quantity barely moved, so that's inelastic. And then proportional would be we change price by some percentage and quantity changes by the exact same percentage. I've been doing this in the context of demand. You could do this in the context of supply also. All right, so to calculate elasticity along a demand or supply curve, economists use the average percentage change in both quantity or price. Well, to be clear, economists teaching introductory micro and microeconomic principles use the average percentage change in both quantity and price. There's other formulas, there's other ways to calculate elasticity. This is the one that's nice for students to know. This is the midpoint method for elasticity. Officially, probably if you're doing this like for real, you'd be using something closer to the point method for elasticity, and you'd probably be doing that with calculus. Actually, you'd probably be doing this with a regression analysis, but this is a good starting point anyway. I just wanted to clarify that. Okay, so the midpoint method for elasticity: percentage change in quantity equals percentage change in price equals. Let's see, will the slides fill this out or not? Let me see here. Should I? It's not going to. Okay, I'll have to talk through this then. So the percentage change in quantity, when we're using the midpoint method, it's going to be Q2 minus Q1 divided by the average quantity. And let's see, if this is not, usually I do this on a PDF, so usually it's a lot different for me to change this. Okay, right, so percentage change in quantity is Q2 minus Q1. I know I'm typing right next to my microphone, so I know that's super loud. Sorry about that. So this is the change in quantity. And then to make it a percentage change in quantity, we divide by the average quantity, right? So that's all that is. Then we divide that whole thing by the percentage change in price. Oh, I like how that was like way bigger. This is so weird. All right, whatever. So my percentage change in price, this font is not doing what I want it to do. Percentage change in price is going to be P2 minus P1 divided by the average price. Now, the aforementioned point elasticity would just be dividing by not average quantity. It would be dividing by Q1 and then not average price, but P1. I've got a YouTube video that talks about the point elasticity and the midpoint formula separately. But this would be the midpoint formula. Then we'd have, I should put a shape in here, right? So this is my division bar. I know this looks weird because I've got my quantity, my percentage change in quantity, much smaller than my percentage change in price. If you believe this graphic I've made, we've got a big percentage change in price, small percentage change in quantity. So this will give us inelastic demand. Yeah. Well, anyway, this is the midpoint formula. Your Q2 minus Q1 divided by the average quantity, P2 minus P1 divided by average price. The brilliance of the midpoint method, and the reason why economists use this for teaching elasticity, is it doesn't matter which one you set as Q1 or Q2. Matter of fact, I could have written this just as right, or it'd be just as right if I wrote this as Q1 minus Q2 and P1 minus P2. And the idea is like you're going to get the same percentage change either way. You do have to care. You can't switch. Like if this is Q2 minus Q1, this can't be P1 minus P2. It's got to be Q2 minus Q1 and P2 minus P1, or P1 minus Q1 minus Q2 and P1 minus P2. Okay, this is the way I want you to remember the formula though. Q2 minus Q1, which is literally a change, and then divided by the average quantity. And then that whole thing divided by P2 minus P1, literally a change, divided by the average price. And the reason why I teach it that way is because look what they're going to have in the next slide. They're going to have the actual midpoint formula. And the midpoint for, they don't actually have it here. They've got a numerical version. So this is Q2 minus Q1. And then this right here, this 3,000 plus 2,800, this whole thing divided by 2, that's an average, right? So the way that you do this, usually the way that they'd write this out would be Q2 minus Q1. And then this would be Q2 plus Q1 divided by 2. And you have all these Q1s and Q2s flying around. It's really hard to remember what you're doing. That's why I say remember the formula like this. Q2 minus Q1 over average quantity, P2 minus P1 over average quantity, because that's a lot easier to remember. Okay, this is applying the midpoint formula, right? So this is saying price elasticity of demand is calculated as the percentage change in quantity divided by percentage change in price. So the elasticity of demand between these points is 0.45, an amount smaller than 1, showing demand is inelastic. Which 2 points are we using? I guess we're using these points right here for between A and B. And the brilliance of the midpoint formula is it's going to give us the same elasticity, 0.45, whether we're going up the curve and we've got a price increase, or down the curve and have a price decrease. Because actually, right where their brackets are, it's actually going to give us the price elasticity right here, actually like right here on this line. So it's going to use one of these as 0.1, the other one as 0.2, and it's going to give us the price elasticity of demand, not here, but actually right here. It's going to give us the price elasticity of demand at the point 65, 2,900, 65. That's where it's going to give us the elasticity. That's why it's the same both ways, right? Okay, so I talk about that in my Substack and in my other midpoint elasticity YouTube video. But that's what's going on here. Okay, here's price elasticity of supply. It's the same formula, right? So it's percentage change in quantity. So it's going to be new quantity minus old quantity, and then average quantity. And then new price minus old price, and then average price. And you don't have to worry about the sign, because if you are consistent with Q1 and Q2 and P1 and P2, or vice versa, then you'll get a positive value for price elasticity of supply because you have an upward sloping curve, and you always get a negative value with price elasticity of demand. So this is they were a little bit sloppy here. I didn't catch this. That was my mistake. So price elasticity of demand is negative, right? Because we have the law of demand. We have a downward sloping demand curve. And so if we have an increase in price, we have a decrease in quantity, or a decrease in price, we have an increase in quantity. So we're going to get either a negative and a positive, or a positive and a negative. So this should be negative. What they're doing here, though, is what a lot of economists will do, which is report the price elasticity of demand in absolute value. So the price elasticity of demand we calculated here was minus 0.45, but the price elasticity of demand in absolute value was 0.45. With supply, by the law of supply, we have an upward sloping, positive sloping supply curve, so it is just like 3.53. We could take the absolute value, but that's not going to affect it because it was positive either way. All right, so what category of elasticity does this result fall into? Oh, look at this fraction here. So we have a bigger numerator, smaller denominator. So bigger change in price, bigger change in quantity, smaller change in price. Change price a little bit, quantity jumped a lot, right? Okay, that's pretty elastic, that's pretty responsive. This is elastic supply. And I like teaching it that way because that gives a little bit greater context to the other rule, which is if the elasticity is greater than 1 in absolute value, it's elastic. If it's less than 1 in absolute value, it's inelastic. Okay, so here's the polar cases, infinite or perfectly elastic. So that means there's an infinite amount, infinite elasticity. So quantity changes by an infinite amount in response to any change in price. So this would give us a horizontal demand curve, right? So the idea is the slope of this thing is 0, right? Or sorry, so we'll have, so let's see, slope is, so we'll have, our change in price is 0. Here's the issue. Our change in price is 0. Our change in quantity is whatever it's going to be. And so our percentage change in quantity divided by our change in price is going to be 1 over 0. So it's undefined. And so that's infinite elasticity. Okay. Zero elasticity, or perfect inelasticity, is where no matter how much the price changes, the quantity doesn't change. So here we have whatever is our change in price, no change in quantity. So now we have 0 divided by something. 0 divided by anything is 0, so we compute our elasticity as 0. So a vertical demand curve or vertical supply curve is perfectly inelastic. A horizontal demand curve or horizontal supply curve is perfectly elastic. The other thing that you want to keep in mind is relatively elastic and relatively inelastic. If you have a relatively flat curve, then it's relatively elastic. If you have a relatively steep curve, it's relatively inelastic. Okay, so constant unitary elasticity. So this happens if a price change of 1% gives us a quantity change of 1%. This demand curve here does that. So here we have constant unitary elasticity. It's going to be a curved line. So we see price and quantity demanded change by an identical amount at each step along the demand curve. Apart from this text, this is relatively uncommon to see in the principles or introductory level economics course, sometimes in intermediate micro, certainly in PhD level. Okay, so here's constant unitary elasticity for supply. It's a straight line reaching up from the origin. So this has a slope of 1, right? So between each point, the percentage change in quantity demanded is exactly the same as the percentage change in price. Okay. Most businesses face a day-to-day struggle to figure out ways to produce at a lower cost as one pathway to their goal of earning higher profits. However, in some cases, the price of a key input over which the firm has no control may rise or fall. Can businesses pass costs or cost savings on to consumers? Well, that has to do with, is demand or supply more inelastic or elastic? So here's an example, passing along cost savings to consumers, technological improvements, right? So we have an increase in supply due to that technological improvement, but we have very inelastic demand. So we are going to get a pretty big decrease in price and a small change in quantity. Here we have the same rightward shift of supply, but we have very responsive demand. So we have a very small change in price and a very large change in quantity. So the takeaway, cost savings gains will cause supply to shift to the right. So at any given price, firms are willing to supply a greater quantity. If demand is inelastic, the result of the cost-saving technological improvement will be substantially lower prices. If demand is elastic, the result will be only slightly lower prices. Customers benefit in either case, either from a far greater quantity at a lower price, but the benefit is greater when demand is inelastic because they get a lower price. Let's see. Yeah, okay. I'm a little bit suspicious of some of their. Anyway, so passing higher costs to consumers, raising taxes. So usually at this point in the course, we would have, before we talk about this, we would have introduced tax incidence, but this is close. We can get a little bit into this example without having to do that. The basic idea is, well, if you have higher costs with inelastic demand, then here demand is more inelastic than supply, and so this is a situation where the cost increase is largely passed on to consumers in the form of higher prices without much decrease in quantity. If demand's pretty elastic, the shift in supply gives a primarily lower equilibrium quantity. Consumers don't benefit in either case, but they pay a higher price for the same quantity, and they must buy a lower quantity. So this is, if we raise taxes, this is effectively reducing, it's like increasing the cost, reducing the supply at all possible prices, reducing the quantity to all possible prices, or just reducing supply. And so we'll get a higher price, lower quantity if demand is really inelastic. Consumers just pay a much higher price. They don't really change their habits very much. If demand's pretty elastic, we get a similar reduction in supply leads to a big reduction in demand. Policymakers, if you want to get people, this is cigarettes, if you want people not to smoke, you're hoping that demand is pretty elastic. But if you're hoping to raise money, raise tax revenue from people that buy cigarettes, then you want demand to be pretty inelastic, right? So there's kind of perverse incentives where the behavioral change effect and the tax revenue effect of a tax are at odds with each other. Okay, we'll talk a little bit about tax incidence, although we haven't really talked about how a per unit tax is applied. If you're curious, you can look at my Substack where I introduce how we calculate or how we model a per unit tax. Tax incidence refers to how is the tax burden divided between buyers and sellers. So if demand is more inelastic, consumers bear more of the tax burden. If supply is more inelastic, sellers bear more of the tax burden. And the idea is like counterintuitively, if you have a tax where you impose an additional tax on buyers or an additional tax on sellers, whether it's for cigarettes or something else, both sides of the market are affected, presumably. It's not just that the tax stays with buyers or tax stays with sellers. And how the impact of the tax is born depends on relative elasticity. The reason why is if demand's more inelastic, consumers have fewer alternatives than just paying the tax. So they buy at a much higher price. If supply is more inelastic than demand, sellers have fewer alternatives than just operating the market and paying tax. What happens on the more elastic, the more responsive side of the market? Well, if demand's more inelastic than supply, buyers have to keep buying whatever this is, but sellers don't have to keep selling in that market. So maybe you have a situation where buyers are stuck in a particular geographic area. But sellers can sell in multiple markets. And so if you impose a tax at the county level or something, that's going to affect buyers in that county or in that state or in that country. But the sellers presumably can sell in lots of different markets, so they can avoid that tax. If supply is more inelastic than demand, this is like sellers are stuck in that particular area. They'd be like local hospitality establishments, like a hotel or something. Like the hotel's pretty much there. Buyers definitely have way more elastic demand. You can drive somewhere else or take a vacation at a place where you have a different hotel or whatever. And so sellers bear the larger part of the tax burden because they're so less flexible in terms of their alternatives than just paying the tax. Okay. An excise tax introduces a wedge between the price paid by consumers and the price received by producers. Oh, okay. So now we're gonna talk about tax incidence. All right. Yeah, so we can do that. So the idea is, here is our original demand, here's our original supply, and we're imposing a tax of this height right here, right? So that this is the size of the tax. This is a per unit tax. So the idea is, for each unit that we're selling, you have to pay some amount, right? And so a good example of this would be for gasoline, petrol, or something like that. Maybe there's like a local tax on each gallon or liter. Okay, so this raises the price. And the idea is, well, either the buyers or the sellers have to pay that tax to the government. As a result, though, of incorporating that tax into the transaction, there's going to be a gap between what comes out of consumers' pockets and what stays with sellers. And that gap is going to be exactly the size of the tax. So when there's a tax applied, buyers have to take more out of their account or more out of their wallet. Maybe they deduct the tax first and send it to the government. That'd be a tax on buyers. Or they give it to the seller, and then the seller skims off the top the money to take to the government and puts the rest in their account. Either way, there's going to be a difference between PC, that's the amount that are paid by consumers, and PP, that's the amount that's kept by sellers. Tax revenue is going to be the amount of the tax multiplied over the units actually sold. It's a rectangle. We see tax incidence. We can measure who's bearing the larger share of the tax by how much that their respective price is, in the case of consumers, above, or in the case of sellers, below the original equilibrium price. So here, staring at this, if this is the original equilibrium price, the new price that consumers are paying is a little bit higher than the original equilibrium. But the new price that sellers receive is way lower. And so this is a situation where the tax is primarily borne by sellers. They're bearing a larger burden. We get that because demand is relatively flat, supply is relatively steep. But contrast that with this one, where now demand is relatively steep and supply is relatively flat. Now we have the same exercise, same size tax. Here's PC, here's PP. The size of the tax is the difference between PC and PP. Formally, it's like PC minus PP. And we can tell, PC is a lot larger than PE than is PP smaller than PE, which is just to say buyers are paying a much higher price than they were before. Sellers are receiving a little bit lower price than they were before. So majority of this tax is borne by buyers. And that's all that this is saying right there. Okay. So elasticity in the long run and short run. Elasticities are often lower in the short run than they are in the long run. In the demand side, it's sometimes difficult to change the quantity demanded in the short run, but easier in the long run, right? So if you find that the price of gas has risen dramatically or fallen dramatically, you're not going to really change your purchasing patterns on that day, right? Because you have to get home or you have to get to work or whatever. But if you find gas prices are rising substantially, now over the long run, you might have an incentive to buy an electric vehicle instead, right? On the supply side of markets, producers of goods and services typically find it easier to expand production in the long term of several years rather than the short run of a few months, right? So immediately, if there's a tax or if some shock to the market, supply is pretty inelastic in the short run, but much more elastic in the long run because they can change their production plans. In most markets for goods and services, in the short run, prices bounce up and down more than quantities. True, because prices move around a lot. Quantity doesn't move very much. That's kind of definition of inelastic. In the long run, quantities move more than prices. Yeah, there's long-term trends. People move away from consuming cigarettes because either the tax increase or regulation makes it more difficult to be able to smoke. Also, then maybe rising gas prices discourage people from buying gasoline vehicles, and they switch on average towards electric vehicles or more fuel efficient vehicles. That's a long run story, not a short run story. Okay, so let's see. Let's try to switch the slide and did that. All right, responsiveness to price changes of crude oil. Yeah, perfect. So this is million barrels per day as our quantity, price in US dollars per barrel as our vertical. Here we have, let's see, here we have our demand. Relatively inelastic, we get a leftward shift to supply. So price rises a lot, quantity didn't change by much. Here we have a leftward shift to supply, but we have a relatively elastic demand. So now price changes a little, quantity changes a lot. All right, so what does this say here? The intersection E naught between the demand curve and supply curve is the same. The shift to supply to the left from S naught to S1 is identical in both. Okay, maybe there's an optic illusion. This one looks a little bit closer. It could be optic illusion. It's intended to be the same, though. I'll trust them. New equilibrium E1 has a higher price and lower quantity than the original equilibrium in both A and B. However, the shape of the demand curve is different. Yep, this is more inelastic. This is more elastic. As a result, the shift in supply can result in either a new equilibrium with a much higher and only a slightly smaller quantity, or a new equilibrium with only a small increase in price and a relatively larger reduction in quantity. Yeah. That's right. So this would be like over a short time period, and this would be like over a long time period. All right, elasticities other than price. Sorry, I got a cold. Right, so income elasticity of demand. Here, notice the numerator is still percentage change in quantity. We just swap out price for income, or income for price in the denominator. So percentage change in quantity demanded divided by percentage change in income. You'd use a similar midpoint formula, but then it's going to be Q2 minus Q1 over average Q, I2 minus I1 over average I. Okay, so for most products, most of the time, income elasticity of demand is positive. So a rise in income will cause an increase in quantity demanded. Those are normal goods, right? Normal goods are where as income rises, you buy more. For an inferior good, as income rises, you buy less. And then, for a normal good, income elasticity is positive. For an inferior good, income elasticity is negative. Usually we don't pay too much attention to the magnitude, to the size of the elasticity. However, if it's bigger than 1 in absolute value, you know it's pretty income elastic. Sometimes we'd say if income elasticity is positive, it's a normal good. If it's between 0 and 1, it's a necessity. And if it's greater than 1, then it's a luxury. Okay, so cross elasticity. This allows us to tell, do we have substitutes or complements, right? So change in price elasticity, or change in the price of one good can change the quantity demanded of the other. So cross elasticity is the percentage change in quantity of good A that's demanded as a result of the percentage change in the price of good B, right? So this is the percentage change in quantity, and we're looking to see how does a change in price of one good cause a change in quantity of the other, right? So if we have substitutes, the goods are used in place of each other. If we have complements, they're used together. So if there's substitutes, we get something like an increase in the price of Pepsi causes an increase in quantity demanded of Coke. So that's positive. Or a decrease in price of Pepsi causes a decrease in quantity demanded, or decrease in demand for Coke because people are buying more Pepsi. So you'll have a positive cross elasticity for substitutes. You'll have a negative cross elasticity for complements. So it'd be like an increase in the price of ice cream cones means you buy fewer ice cream cones, but you also buy less ice cream. Or a decrease in the price of ice cream cones means you buy more ice cream cones and then you buy more ice cream. So those are opposite signs. Okay, what are examples of complement and substitute goods where the change in price of one good causes a change in demand of the other? Oh, yeah, I gave examples just a second ago. All right, so elasticity in labor, so wage elasticity of labor supply, percentage change in labor supply divided by percentage change in wage. Okay, so we could apply, we have a price elasticity of supply. We also have a price elasticity of labor supply. We also have the price is a wage in the labor market. And similarly, we have a price elasticity of demand. We have a wage elasticity of labor demand. Basically behaves just like a regular elasticity. Okay. And then interest rate elasticity. We have our interest rate elasticity of savings. So percentage change in quantity of financial savings divided by percentage change in interest rate. And then our interest elasticity of borrowing, that's analogous to the price elasticity of demand. So percentage change in the quantity of borrowing divided by percentage change in interest rates. Right, okay. I don't know. These are interesting, I guess. Back to Netflix. How did the 60% increase in price in 2011 end up for Netflix? Before the price increase, there's 24.6 million US subscribers. After the price increase, there's 810,000 US consumers canceling their subscriptions. So fast forward to 2013, there are 36 million streaming Netflix subscribers. Average growth per quarter is about 1.6 million. This is less than 2 million per quarter increases that have been the previous norm. So why was the estimate of customers leaving so far off? What missteps did management make? Well, they misjudged elasticity of demand. So due to the increase in number of close substitutes, right? So people were willing to switch. Also misjudgment of consumers' preferences and tastes. So maybe people still preferred the physical DVD over streaming back at that time. It's a little bit difficult to use this kind of empirical data if we're like external observers, because we're not holding constant the other things that could affect price or especially quantity. Implicitly, what we're trying to do with elasticity is we're saying the price change caused the quantity change, right? Or here we're trying to say the change in interest rate change that caused the change in financial borrowing. And so this example, though I like it, I like what they're doing, there's a challenge here, and that's that the 60% price increase, yeah, we're trying to attribute this change in quantity demanded to that price increase, and a lot of it might have been, but there could have been other factors. So if you're actually doing elasticity work and you're trying to calculate elasticities, you want to observe all the other variables that could also be like demand or supply shifters and hold those constant so that you can credibly claim that the elasticity is tracking specifically, the percentage change in quantity is due to that specific percentage change in price. But anyway, hope you enjoyed the video here. Go ahead and conclude. I'll see you in the next one.